It is moving with a velocity, initial velocity v naught, and let this be at rest. This is the first object, second object. They'll collide. So I want the maximum deformation energy or minimum kinetic energy of system. So when they come and collide, here they will start, impulse will act, and finally at one position, both will move with a common velocity. So here if you want, you can show like deformation. Then again, I have to show deformation. No? So here it will be V1 double dash, V2 double dash. Just show that impulse, don't bother. Reformation, deformation, or we'll do one thing. Why to confuse you? Finally, what will happen? I'll see that this will come to rest. This will be moving with the same speed. So here is what kinetic energy will be minimum. The deformation energy, I'll write ED. This will be maximum. What is ED? Deformation energy or potential energy. How to calculate that? I'll apply conservation of linear momentum. From where? From the initial to the final, and the initial. Between initial and the point where they will have a common velocity. That's how you can say here only the deformation maximum. Go back to spring block system. At maximum elongation or compression, what should be the velocity of the ends of the spring? Should have common velocity, and that should be equal to velocity of center of mass. Recollect, those ideas are very important. Applying conservation of momentum, mv naught should be equal to m1. Masses are same, no? We took same masses. M plus m into v. So what is v equal to? V naught by 2. Let's calculate the initial kinetic energy. Should be to kinetic energy at deformation or minimum kinetic energy plus maximum deformation energy. What is the initial kinetic energy? M v naught square by 2. Minimum kinetic energy, m plus m, mass of the system, v square by 2 is equal to maximum deformation energy. So let's calculate this. M v naught square. This will be only mv square. What is v equal to? V naught by 2. Oh, just wait, some symbols here. It should be like this. Huh? What I'm conserving here? Anybody? Total energy should be conserved, no? Don't say kinetic energy is conserved. Again, I'm making things very specific. What was the initial energy of system? Kinetic energy. Then at maximum deformation, the energy will be there in the form of kinetic plus also potential energy. So total energy is conserved. Total energy remains constant. Energy is always conserved, no? So here kinetic energy remains constant is a wrong concept. The total energy is conserved here. So that I'm applying it here. So now solving this, how much will get? This is equal to ED is equal to m v naught square by 4. What was the initial kinetic energy? M v naught square. What was the initial contingent mv naught square? So shall we write it half of this one? So what is the maximum deformation energy? How much it is? Which is half of the initial contingent. So at this
Sir,
particular point,
you missed a half over there, sir.
okay, I'll check calculation once. So this should be half mv square half m plus m. Mass of the system is m plus m, no? 2m v square by 2.
Okay, sir. Okay, sir. I made a
Okay,
mistake.
check it. Yeah. Okay, fine. So this is the maximum deform or minimum contingent. How much will be half of the initial? Or what is maximum deformation G will be this much. Sir, you took masses same. I'll take 1 kg, 2 kg. Okay, you do try it. Yeah, this is one example. I'm telling this one for this given situation. So how to calculate that maximum deformation of energy during collision? There's a method. Maximum deformation energy, or some books they call it as potential energy. Both are same. Okay, this is what overall happens in elastic collision. So kinetic energy remains constant is the wrong statement. Kinetic energy is conserved is what the statement I'm giving this particular proof. Now, so like both are moving, then both are moving also, then only at one instant both will have common velocity. What is the condition? The velocity of the one should be more than two, then only can collide, no? Then only it can collide. So here to study this collision, so I'm to study the nature of collision, what happened? Definitely I need one parameter. So that I'll call it as coefficient of restitution. I'll go for now. So let me consider. So these are the objects are there. M1, it is moving with the initial velocity u1.